minus 100. Then you can get this n value from this particular case is 550 degree n. 550 degree n. So now you have got this particular answer. Then what about the other case here? Then the other side is that here what you have to consider that here something that is this degree n is nothing but equal to this degree n is nothing but equal to that degree centigrade C. So for a thermometer property as x, for a thermometer property as x degree. So when it is connected to this degree centigrade, that is here. So what this degree centigrade, now you have to find out this degree centigrade minus ice point divided by the steam point 100 minus ice point is equal to the n value here, that is this n minus 100 ice point divided by 400 minus 100, and that is nothing but equal to, where if you consider this as x and this also the thermometer property as x, so x by 100 is equal to x minus 100 divided by 300, then you will get the x value as minus 50 degrees centigrade. So this is what this particular answer, minus 50 degrees centigrade, right? Hope now this is the required temperature. That means always you should have to find this is the pressure minus the pressure at the ice point divided by pressure at the steam point minus pressure at the ice point, or temperature which the required temperature you need to find minus the temperature at the ice point divided by temperature at the steam point minus temperature at the ice point. So this is the formula you have to apply for solving this particular numerical problem. Hope you understood this particular case. So this is the exercise problem from the PK Nagar textbook, and you are going to make the solution like this one. So this is how the methodology you have to observe here. So once after knowing these basic fundamentals, then you can easily calculate the temperature. So this is hope this particular problem is clear. Next, there is another problem that here the another problem which is given that a new absolute temperature scale is proposed. New absolute temperature scale is proposed in such a way that on this scale the ice point of water is 150 degrees centigrade. See, observe the ice point of a water. Ice point of a 150 degree centigrade and the steam point is 300 degree. Yes, that is a new temperature, a new absolute temperature scale. See, observe, it is proposed. So the new absolute temperature scale is at the ice point, it is 150 degree, yes. Steam point is 300 degree, yes. Determine the temperature in degree centigrade that corresponds to the 100 degree, yes, and 400 degree, yes, respectively. What is the ratio of the size of a degree, yes, to the size of the Kelvin? This is what you have to find. So these are the answers. These are the answers. So how you are going to make the calculation for this one? At here primarily it is given that at 0 degree centigrade, the new temperature scale is given as 150 degree, yes. At 100 degree centigrade, at 100 degrees centigrade, the new temperature scale is given as 300 degree, yes, 300 degree, yes. Then what is the relation that you are going to be getting? The relation between degree centigrade and the degree, yes, and the degree C, you are going to be getting the relation as the degree S is equal to, so this is a 300, that is the steam point, minus ice point, that is 100, divided by 300 minus 100 divided by 100. This is in degree centigrade plus 150 plus 150. See here. So plus 150. Now you will get this particular reading as that is this is 200, that is 300 minus so you will get this particular 300 minus 100, it is 200. It is, I think it is 150. 300 minus it is 150. 300 minus 150 plus the initial it is given as 150. So you will get the degree S reading as plus 150. So you will get it as 1.5 degree centigrade plus 150 plus 150 plus 150. So this is the relation. So with this case, now you will get the degree centigrade values as minus 33. You will get it as that particular values as minus 33.3, and another one is 167.67. You will get from this particular relations. From this particular, that is degree yes. So from this particular relation, you will get that particular value, that is the degree centigrade, in two ways. That is already in the previous case also it is the same type of a problem, but here uh, in using this degree S scale is equal to, in terms of this one it is 1.5. Say suppose if you want to make in terms of the Kelvin, so that is K minus 273.15 plus the another it is 150. So the size of the scale, now here the size of the scale which you are going to be getting it as a 1.5 degree S divided by Kelvin. Degree S divided by Kelvin. So this is how you are going to solve this particular new temperature scale. And this particular problem is also given from the, it is also there in the Pekenark textbook. So you can refer that Pekenark textbook, and you can get the solution like this one. So this is one type of a problem to this particular side. Next, there is another that is a platinum resistance wire. So the platinum resistance wire is used as a resistance thermometer. Is used as a resistance thermometer. Now you just observe that the wire resistance was found to be 10 ohm and 16 ohm at ice and steam point respectively, and 30 ohm at sulfur boiling point. See, observe this one. Platinum resistance, just before at the starting of this eighth video lecture, I have given one relation, that is a resistance thermometer. You just go through the first or second slide of this eighth video content, and the sulfur boiling point is given as a 444.6 degrees centigrade. Find the resistance of the wire at 500 degrees centigrade. At 500 degrees centigrade, if the resistance varies with the temperature by the relation. So according to this particular calculation, then you have to use this particular relation as R is equal to R naught into 1 plus alpha T plus beta T square. So this is the platinum wire resistance thermometer. So at the ice point, that is it is given as the 10 ohm. So at the ice point, it is 10 is equal to R naught into 1 plus 0 plus 0, ice point. So ice point, it is 0 degree centigrade, right? Next, at the steam point, it is given as a 30. Sorry, it is at the 16. So it is given as a 16. So that is 16 steam point. So at the steam point, it is given as 16 is equal to R naught into 1 plus 100 T plus 100 square. sorry, this is 100 alpha plus 100 square into beta. So this is one equation. This is a two equation. The third one, that is the sulfur boiling point, is also given. So that sulfur at this case it is given as the 30. See, 30 ohm at the sulfur boiling point. So that is equal to R naught into 1 plus 444.6 alpha plus 444.6 square into beta. So this is the third equation. So from this 1, 2, 3. So from 1, 2, 3 mathematical expression using these relations, now you try to find out the, so from this case, try to find out what is the value of R naught, what is the value of alpha, what is the value of beta. So from 1 to 3, you will get R naught, alpha and beta. After getting this particular value, then again you need to substitute the resistance. So that is that resistance is equal to, so here at the find the resistance of the wire at 500 degrees centigrade. So R naught into 1 plus 500 alpha plus 500 square beta. So after finding this alpha, beta and R naught, you will get that particular resistance as 31.3 ohm. You will get that particular resistance as 31.3 ohm. So this is how you have to solve this particular numerical problem into this particular site. Hope you have received that particular case. So this is one problem in zeroth law of thermodynamics. That is, there are the various temperature scales are there. What are the temperature scale? That is constant volume gas thermometer is there, constant pressure gas thermometer, resistance thermometer. Next one is a thermocouple is there, digital thermometer is there. So like that one, the different Wheatstone's bridge resistance thermometer. So there are the different varieties of thermometers are there. And here there are certain relation, that is T degree F is equal to, so the relations T degree F is equal to 1.8 T degree centigrade plus 32. When T degree centigrade is 21, then what is the value of T degree Fahrenheit and what is the value of these relations? So these relations at T degree centigrade 21, apply that one, you will get the values as this one. Just only for showing the relation purposes. When T degree centigrade is equal to minus 40, substituting that in this particular T degree F and T degree R, then values you will get like this. If T degree centigrade is 500, substituting that in Fahrenheit and Rankine scale, then you will get like this one. In T degree, if T degree centigrade is equal to 0 degree centigrade, then what about the Fahrenheit and what about the Rankine scale? So this is how the relations are there. In the same way, the T degree centigrade with respect to the Fahrenheit is given over here. When the degree Fahrenheit value is 68, then what about the degree centigrade value and what about the absolute Kelvin value? So there are the different situations are there. So try to go through that particular problem. Try to go through that particular side so that you can get the knowledge onto this particular side. Next. So there is one more problem here. This is a thinking level question. This is a thinking level question. What is that particular question? Here it is shown that, so as shown in figure, that is, this is the figure, and here there is a pipe, a small diameter water pipe, small diameter. So a small diameter water pipe passes through 6 inches thick exterior wall. So this is the wall is there. So in that wall, a 6 inches diameter pipe is passing through the wall. If the temperature varies linearly with the position, so if the temperature varies linearly with the position x through the wall from 20 degrees centigrade, so at the left hand side it is 20 degrees centigrade, and the right hand side it is a minus 6 degrees centigrade. In between that one there is a pipe which is passing through the wall at a distance of 3 inches. The total length of the wall is 6 inches. Out of that one, central portion is through the central portion the pipe is passing, and would the water in the pipe gets freeze. Why? Here the value is given as a 20 degree centigrade, and at the outside the value is given as a minus 6 degree centigrade. Now I have a doubt whether this particular water is going to be frozen or whether this particular water is going to be clogged into this particular pipe. So this is what you need to solve. Sometimes the problems are in a realistic situation, especially for the thermodynamics point of view. So how you are going to solve this particular case? Then here it is mentioned if the temperature varies linearly with the position x. So that temperature where in this particular case you can take it as a mx plus b or mx plus c. So this where m is nothing but equal to the slope. So that slope is nothing but the change in temperature divided by the length. So what is that change in temperature? It is minus 6 degrees centigrade minus 20 divided by 6 inches. So you will get the slope. Now at the left hand face, so at the left hand face, that is here temperature is 20 degrees centigrade, and now you will get the m value, but x is equal to 0. So at the left face, x is equal to 0, and in that case the temperature is 20 degrees centigrade is equal to where x is 0, that means this is 0 plus b. So you will get the value of b in this particular case. Then what you have to calculate? You have to calculate this case, that is whether the water is going to be gets frozen or not. So that is the t is equal to, you will get the slope from this particular case. So minus 26 divided by 6. So more or less you will get it as something 4.5. So that the slope is 4.5. So this slope is minus 4.5. So minus 4.5. X is 3 inches because this one 3 inches plus and this value. So it is 20. So you will get it as around the temperature. If the value is in between this minus 6 and 20, then water, danger of water frozen, danger of water gets frozen. So that particular things you can find out from this particular type of a problem. So it is a the thinking level question. Sometimes you will experience from this particular types of a problem. So this is one model type, that is the t is equal, the thing is that t is equal to mx plus c, that is the linear relation. The water passes through the 6 inches thick exterior wall of a dwelling if the temperature varies linearly with the position x. So that you should, that thing it is to be strike in your mind. T is equal to mx plus b. So if you substitute that case, then you will get that particular case. So hope I think this is once again the problem is repeated, the same variety. So you can also go through, but here with different numericals, different numericals. So in the previous classes we have also discussed the understanding level questions. That is already we know that the intensive properties and extensive properties. So in this particular case, if you just observe that whether it is a property or not, because we have covered the intensive property and extensive property. So integral of PdV, whether it is a property or not. Integral of VdP, whether it is a property or not. What about this case? So integral of PdV, because the P is a function of V, and the integral can only be evaluated if the relation between P and V is known. So it is thus an inexact differential, because PdV work is nothing but it is an inexact differential work, and hence it is not a property. So that's why work and heat are not the property of a system. Work and heat are not the property of a system. Next, there is a VdP. So it is also not the property for the same reason, because here V is a function of P and the relation. The third equation, that is PdV plus VdP. What about this one? So integral of PdV plus integral of VdP, that you can write it as integral of PdV plus VdP. So that is integral of differentiation of PV. So you will get this particular relation. So finally it is nothing but equal to PV work. So thus the integral can be evaluated without knowing the relation between P and V. So it is an exact differential and hence it is the property of a system, and hence it is the property of a system. So this is